Example 31, water flows in a triangular channel having sides sloping 1:1 and a depth of 0.4 meter if roughness coefficient is 0.015 and the bed is laid on a slope of 0.009. Determine the following: the flow rate, the Froude number, the alternate depth of flow, the critical depth. Then, can a hydraulic jump occur? What is the energy dissipated in watts? So let's draw the figure in general so that we can analyze this situation. So since the slope is 1:1 for the sides, so if the depth of flow is d, then the top width b, capital B, is 2d, because that's d and that's also d. The area therefore is 1/2 of 2d times d. So the area in general at any section is d square, depth square. So Q is area to the 5/3 slope to the 1/2 over n perimeter to the 2/3, where the area is zero point 0.4 square or 0.16 at this section here. Then perimeter is, this is d square root of 2, d square root of 2, so 2d square root of 2. 2 times depth square root of 2. 2 times 0.4 square root of 2 is 0.8 square root of 2 meter for this section, and the depth of flow is 0.4. So substitute Q equals 0.16 to the 5/3 times 0.009 raised to 1/2 over 0.015 times perimeter quantity 0.8 square root of 2 to the 2/3. So the discharge is 0.2747 cubic meter per second. So the Froude number, because this is non-rectangular, is velocity, mean velocity over square root of g hydraulic depth. So that's the formula in general for non-rectangular section, where hydraulic depth at section 1 is simply area 0.16 or d square over top width, which is 2 times the depth. So V1 is Q over area 1, 0.2747 over 0.16, so it is 1.717 meters per second. Then substitute FR1 is 1.717 over square root of 9.81 times 0.16 over 0.8. The top width is 0.8. Remember hydraulic depth. So FR1 is 1.226, which is greater than 1. So when the depth of flow is 0.4, this happens, or the flow is supercritical, and therefore a hydraulic jump can occur because it begins with supercritical flow. Remember the phenomenon on hydraulic jump, it will only occur if the flow is from supercritical. Then after the jump, it becomes subcritical. The Froude number is expected to be less than 1 for that case. So the alternate depth of flow. So remember the principle, specific energy in the lower and upper stages will be the same. So E sub 1 is velocity head 1.717 square over 19.62 plus 0.4. So it is equal to 0.5503 meter. And this is also the specific energy for the alternate depth of flow by principle. So 0.5503, which is velocity head at section 2 plus depth 2. So 0.5503 equals 0.2747 over depth 2 square. Remember, area 2 is depth. Area in general is depth square. So at section 2, the area is depth 2 square. So Q over area 2 is V2. And quantity square over 19.62 plus D2. So using your calculator there, depth 2 is 0.4743 meter. So next is, so the jump is very small because from 0.4 it becomes 0.4743. So expect also a very small head loss. Then, because the Froude number is very close to 1 also at section 1. So next is the critical depth. So formula for critical depth for non-circular section is capital Q square over G equals area cube over top width, if you can remember. So substitute Q is 0.27. By the way, area is depth critical square. Area is depth square, so depth critical square. Top width is 2 times depth critical, because this is the critical depth formula for non-circular, non-rectangular sections. So 0.2747 quantity square over 9.81 equals depth critical square raised to 3 over top width 2 times depth critical. So 2 times 0.2747 square over 9.81 equals depth critical to the fifth. So therefore, critical depth is fifth root of 2 times 0.2747 square over 9.81. So you can easily compute using your calculator. So critical depth is 0.4339 meter. 0.4339 meter. Then the question on, can a hydraulic jump occur? So we already answered that yes, because it begins with supercritical flow. So what is the energy dissipated? So let's compute for the depth after the jump. The depth after the jump is not the alternate depth. It's different, as mentioned or explained in the lecture part. So we use the general formula for hydraulic jump for non-rectangular sections. If you can remember, F2 minus F1 equals mass flow rate Q rho times quantity V1 minus V2, where we have not yet computed V sub 2 corresponding to depth. Uh, this is not depth 2, this is the alternate depth of flow. This is the depth in the upper stage. So expect a different depth. So this is specific weight of water, barred H area, where barred H is depth over 3 because this is triangular section. So the distance from water surface to centroid is 1/3 of depth. Then the right side, cubic meter per second times density times meter per second is newtons. The left side, if you use 9.81 for specific weight of water, is kilonewton. So we divide the right side by 1000 to match with the units at the left side. Kilonewton, so the right side should be in kilonewtons also by dividing 1000. So 9.81, depth 2 over 3, area 2 is depth 2 square, minus 9.81 times barred H1 is 0.4 over 3, area 1 is 0.16 or 0.4 square, equals Q, density of water 1000 kilogram per cubic meter. We divide 1000 to match the unit at the left. Then quantity V1 1.717 minus V2, which is Q over depth 2 square. So simplifying, this is 9.81 over 3, 3.27 depth 2 cube. Then because this is cancelled, then minus plus, sorry, 0.2747 square over depth 2 square. Then let's combine the constants. So 3.27 depth 2 cube plus 0.07546 over depth 2 square. Then negative 9.81 times 0.4 over 3 times 0.16 minus 0.2747 times 1.717 is negative 0.68094 equals 0. So this is this is an equation with polynomial equation with 5 degree, because this becomes raised to 5. So using the high-tech calculator or by trial and error, it will take time. So depth 2 is the correct root for depth 2 is 0.4698 meter. So it should be greater than 0.4 but lower than but close to 0.47. So that's it for the depth after the jump. Let's now proceed to computing the head loss first in the jump, which is specific energy at 1 minus specific energy at 2. So V sub 2 can now be computed. So V sub 2 is discharge 0.2747 over depth 2 square, the area at section 2 after the jump. So it is 1.245 meters per second. So substitute head loss in the jump is 0.5503 minus 1.245 squared over 19.62 plus depth 2.4698. So the head loss in the jump is 0.001498 meters. Take note, you cannot use the formula quantity depth 2 minus depth 1 cube over 4 depth 1 depth 2. That was for rectangular sections. This is not a rectangular section. So power loss or energy dissipated in watts is Q specific weight of water times head loss. So 0.2747 times 9,810 newtons per cubic meter times 0.001498. So the power loss or energy dissipated is 4.037 watts. So that's it for this problem.